Hello, everyone, and welcome to the OneClass channel. My name is Donna and I'm a recent master's graduate from the Materials Science program from the University of Ontario Institute of Technology, also known as Ontario Tech University. So today we're going to go over some commonly asked questions in chemistry at the high school, college, and university level. So if you need any help with homework or tutoring, then check out the links in the description below. Now we're just going to get started on our set of questions for today's session. Okay, so question 1 asks, what is the total bond energy per mole needed to break all the bonds in methane CH4? Okay, so first let's define what bond energy is. So bond energy is the measure of bond strength to convert one mole of a molecule into its constituent atoms. So in other words, it is an amount of heat that is equal to the bond energy that needs to be put in. Okay, so bond energy can depend on different factors. It can depend on the electron affinity of atoms. The size and electronegativities of atoms. And also the bond length. Okay, so now let's get to our example. So for example, let's draw out methane. It is a single carbon bonded to 4 hydrogens. Okay, so now let's look up the average CH bond energy, which is around 405.5. So let's round to, that should be fine. Okay, so we just need to multiply this by 4. Since there are 4 carbon-hydrogen bonds in methane. They set it up here too. It's around 1662. Okay, so let's see what the junior tutor said. In definition, bond energy is the measurement of the strength of a chemical bond. When a substance undergoes chemical reactions, bonds are broken up to make way for the formation of new bonds. The energy required in breaking bonds and making new ones is called the bond energy. Bond energy is dependent on the following factors: the electron affinities of atoms, the size and differences in electronegativities of atoms involved in the bond, and also increasing the bond length decreases the bond energy. So the average bond energy for the carbon-hydrogen bond is 414 kilojoules per mole. Therefore, the total bond energy of methane is 1656. Yep, so the solution is correct. They just had a different average bond energy for carbon-hydrogen, but it is pretty close to what I had as well. Okay, so we can move on to question number 2, which is what is a binary compound? Okay, so even just trying to analyze the word, it has a prefix of bi, which can stand for 2. So this kind of gives us a hint of what a binary compound is. And basically it consists of 2 elements. So the elements don't need to be in like a 1-to-1 ratio. Like we could just have H2O. It's only composed of hydrogen and oxygen, hydrochloric acid, or carbon dioxide. These are all examples of binary compounds. Okay, so the junior tutor said, a binary compound is a compound that consists of precisely 2 elements. An element is a substance that cannot be broken down into simpler substances through chemical methods. Examples of binary compounds include sodium chloride, NaCl, water, H2O, carbon dioxide, CO2, and nitrous oxide, N2O. Yep, so this solution is correct. Okay, so question 3 just asks, what is the molar solubility of a compound C2D3 given its solubility product constant? KSP is equal to 9.4 times 10 to the negative 9. Okay, so first let's just define what molar solubility is. So molar solubility is the number of moles of solute that can be dissolved per liter of solution. And then this is before it becomes saturated. So you know a solution starts to become oversaturated when a precipitate starts to form. So there's going to be a moment where you have a concentration of solute that is greater than the molar solubility, and when you start to add more of the solute, then it's not able to dissolve in the amount of solution that you have. So that's why its precipitate starts to form, and you can start to see a solid in the solution. Okay, so back to the example. They just had a general compound, CD23. So this isn't like a real, like, these aren't real elements or anything, but we're going to try and write out what this compound would look like if it was broken up into its ions. So if we had C2D3 solid, it will break up into 2C3 plus ions and also 3D2 minus ions. And the reason I know the charges as well is because I just did because we know that we have C2C atoms in the compound, so we needed 2 of these atoms to neutralize 3 of the D atoms. So if you kind of cross the numbers over, then that's how we know what charges they are. So the C has the subscript of D as its charge, and it's a positive charge. And then the D has the subscript of C, and its charge is negative. Okay, so the question also gives us the KSP value, which is equal to 9.4 times 10 to the negative 9. Okay, so first we're just going to make an ice table. And we can just cross out the column of our reactant since it is a solid. And we're just going to be looking at our ions. So the initial concentration of both of the products is 0, since we start off with 0. And then the change will be plus 2x. And for D, it is plus 3x. So it depends on the coefficient in front of your ions in the balanced chemical reaction. So this shows us that our concentration at equilibrium is equal to 2x for the C3 plus and 3x for the D2 minus. Okay, so now we can write our KSP expression. So for this question, KSP is equal to the concentration of 3 plus to the power of 2. Again, this also depends on our balanced chemical reaction. And our concentration of D2 minus is going to be to the power of 3. Okay, so now we can plug in everything that we know. We know our KSP value is 9.4 times 10 to the negative 9. And we also know the concentration of our C3 plus should be equal to 2x. And this will be squared. And our concentration of D2 minus should be 3x. And this will be to the power of 3. Okay, so we can simplify this in order to make it easy for us to solve. So it's going to be 4, 27, so 27 times 4, 108x. And then when you multiply exponents, you just add the values together, so you get x to the power of 5. Okay, so let's divide both sides by 108. And you should get 8.3 times 10 to the negative 11 is equal to x to the power of 5. And now we just do the power of 1 over 5 for both sides, which gives us an x value equal to around 0.0096. Okay, so this is the molar solubility of the compound. Okay, so the junior tutor said, in definition, solubility or molar solubility of a compound is the concentration of the dissolved solids in a saturated solution. Molar solubility can be solved using the given solubility product constant. For the compound C2D3, we can express this as a concentration of C and D in the aqueous solution. To solve for the molarability, let S equal the molar solubility of C2D3 in moles per liter. Concentration of C is equal to 2S, and the concentration of D is equal to 3S. Substituting this to the solubility product constant KSP formula, we'll have 9.4 times 10 to the negative 9 is equal to, I think they just forgot to put the squared and the cubed in the question. But this should read 2s squared times 3s cubed. And then they just solve for their s, but I'm just going to add that what they should have wrote instead. Okay, so I'm not going to write all of the mathematical steps, but I just wrote that the explanation is correct. However, the KSP formula should be KSP is equal to C3 plus to the power of 2 multiplied by D2 minus to the power of 3. And then I showed what the expression should look like. Let me try to put this in square brackets. Maybe it'll be easier to read. I might as well write the next line to make it a little more clear. Okay, so now we can move on to question number 4. What are examples of a cation? So this can be pronounced like cation, people say cation, but generally this is when you have a positively charged ion. So some examples of cations are like Na plus, lithium plus, calcium 2 plus, or even the ammonium ion, NH4 plus. So basically it has a positive charge. Opposite of cation is an anion, which is just a negatively charged ion. So some examples of anions would be like Cl minus or OH minus, or like SO4 2 minus, the sulfate ion. So an easy way that I like to remember which one's which, like which one's positive, which one's negative, is that cation has a T, which also kind of looks like a plus sign. So we know that this is the positive ion. And even with anion, there are 2 N's in it. So negative starts with an N. So anion has the N, 2 N's, and then cation has a T, which is like a plus sign. So that's how I like to remember which one's which. So the junior tutor said, an atom is termed as an ion if it has an unbalanced number of protons and neutrons. I think they meant to say electrons. There are 2 types of ions, cation and anion. Cation is more protons than electrons, thus giving it an overall positive charge. Cations are formed when 1 or more electrons are lost, and the number of electrons lost dictates the overall charge of an atom. As an example, if the elemental zinc loses 2 electrons, it will now be zinc 2 plus. Okay, so the solution is correct. I'm just going to fix the first sentence that they said. think they meant to say unbalanced number of protons and electrons. Okay, but I'll still say the solution is correct. Okay, so question 5 asks, is nitrosyl chloride polar or nonpolar? Okay, so let's draw out this compound. We have nitrogen in the middle. It is double bonded with oxygen and just singly bonded to chlorine. Okay, so let's recall the electronegativities of all of these atoms. Chlorine is the most electronegative, so we'll see a dipole moment pulling in the direction of the chlorine atom. And this is unequal because since chlorine is more electronegative than the oxygen, then it kind of looks like this, where the oxygen isn't electronegative enough to balance out the electronegativity of chlorine. So the dipole moment isn't cancelled out. So therefore, I can say that this molecule is polar. We also know it's not polar because it's not symmetrical. So let's draw out an example of a nonpolar compound. This is if we have carbon attached to 4 chlorines, all of them with the same electronegativity. So their dipole moments are able to cancel out. So C carbon tetrachloride is nonpolar. Okay, so the junior tutor said nitrosyl chloride is a polar molecule. Yep, so this solution is correct. A non-zero dipole moment is created. I'll say due to the differences in electronegativity. Okay, so on to question number 6. How do you calculate the concentration of a substance from its absorbance? Okay, so we can use the equation. Absorbance is equal to molar absorptivity times B times concentration. So A is absorbance, which is unitless. This symbol is a molar absorptivity. And its units are in liters over centimeters times mole. So B is the path length. So it's most of the times it's 1 centimeter, but it just depends on what the question gives you. And then C is concentration. Which is in moles per liter. Okay, so basically when you are given the absorbance, and in the question they also give you its molar absorptivity and also the path length, then we're able to solve for concentration. So that's if they give you molar absorptivity and path length. Sometimes we have to, it might be easier to plot it. So if we plotted concentration versus absorbance, since these values stay constant, like they're just numbers, if we were to plot absorbance and concentration, you would get just like a straight line showing that when concentration increases, absorbance increases as well. So the line can be expressed as A is equal to X times C. So if a question gives you different absorbances at certain concentrations and you need to solve for the unknown, you first would need to plot your absorbances versus concentration. And then using Excel or using Sigma plot, you can find the equation for your line. Can't write today. Find equation of your line. So instead of X, I'll make it M to stand for slope. And then if given absorbance, you can plug it into your equation and then solve for the unknown. Okay, so there are two methods. The first is if you're given molar absorptivity and you're given the path length and you're given absorbance, then you can just plug it in straight into the Beer's law equation. And the second is if you're given multiple points of absorbance versus concentration, you can plot this and then find the equation of the line and find the slope of the line. And then if you're given absorbance, you can plug plug it into the equation, and then solve for your unknown. So the junior tutor said, we have to remember Beer's law, which is absorbance equals molar absorptivity times path length times concentration. By manipulating the equation, we can get concentration. Okay, so that solution is correct. I'll also add method 2. Okay, so I said the solution is correct. Also, if you're not given molar absorptivity or path length values, you can plot concentration as X and absorbance as Y. I should say different values. Depends on what the question gives you. They might give you like 3 or 4 different values. Yeah, you can plot different values of concentration as X and absorbance as Y. Find the equation of the line using Excel or Sigma plot. And then from there, by plugging in absorbance as Y, we can solve for the concentration using the equation of the line. Okay, so on to question number 7. How do you calculate for the moles of a substance when given its grams? Okay, so let's recall that the number of moles is equal to mass over molar mass. So mass is in grams and molar mass is in grams per mole. So molar mass we can find using the periodic table. So for example, the molar mass of water, which is H2O, is equal to 2 times the molar mass of hydrogen plus the molar mass of oxygen. So the molar mass of hydrogen can be found on your periodic table. Molar mass of hydrogen is 1.01. Skipping everything. And the molar mass of oxygen is 15.99. If we add these values up, then we get a molar mass of 18.02 grams per mole for the molar mass of water. And then if we have a substance that they give us the value in grams and they need to have us find the number of moles, then it'll just be that mass divided by 18.02 grams per mole, and then we'll get number of moles of water. So the junior tutor said, to convert grams to moles, we must first know the molar mass of the substance. Then we divide the mass of the substance with its molar mass or multiply the mass with the inverse of the molar mass. Yep. And then they showed their equation. This solution is correct. Okay, so 8 just asks for the molar mass of magnesium. So this is just a single element that can be found on the periodic table. And it's equal to 24.305 grams per mole. And the junior tutor said, the molar mass of magnesium is the same as its atomic mass. Difference is that molar mass is in grams per mole, while atomic mass is in atomic mass units. Since the atomic mass of magnesium is 24.305 AMU, its molar mass is 24.305 grams per mole. Yep, so this solution is correct. Question 9 asks, how do you convert grams per mil to grams per centimeter cubed? Okay, so this is kind of an easy conversion because 1 mil is equal to 1 centimeter cubed. So since the values are the same, if we had 9 grams per milliliter, we know that this is also equal to 9 grams per centimeter cubed. So the junior tutor said, to solve this problem, we need to convert 1 mil to 1 centimeter cubed. We know that 1 mil is equal to 1 centimeter cubed. So solving this mathematically, and then they just showed how the units canceled out. So this solution is correct. Question 10. Draw the organic and inorganic products for the following acid-base reaction. Include charges. Okay. Okay, so first we need to define what is the acid and what is the base. So this reactant is our base because it is the proton acceptor. And this hydronium ion, which has a positive charge, is our acid, since it is the proton donor. So we can draw this mechanism showing that one of the lone pairs of oxygen will take one of the protons, an H3O+, and this will neutralize its positive charge. And then our final product shows a protonated product plus water. So this is our organic product. And we know this because it contains carbon. And a water molecule does not contain carbon, so this is our inorganic product. Okay, so let's see what the junior tutor said. The ketone will accept a proton from H3O+ to produce a protonated carbonyl as shown below. Yep, so this solution is correct. And then I just added which one is organic and which one is the inorganic. Okay, so question 11 just asks, what is the molar mass of calcium phosphate? Okay, so let's say we don't know the chemical formula for calcium phosphate. Let's just break it up into its ions. Calcium is Ca2+, and phosphate is PO4 3-. So therefore, we need 3 calcium ions to neutralize 2 phosphate ions. And I did this just by doing that crossing method, since the charges will be equal to the coefficients of the opposite reactant. So we can write the chemical formula as Ca3 PO4 2. Okay, so now that we know the chemical formula of calcium phosphate, we can find its molar mass. And to do this, we just need to look at the values on our periodic table. So it's going to be 3 times the molar mass of calcium, since there are 3 calcium atoms. 2 times the molar mass of phosphorus. And then there are 4 oxygens, multiply that by 2. So 8 times the molar mass of oxygen. Okay, so finding the atomic mass values from the periodic table. For calcium, it's 40.08. grams per mole. Phosphorus is 30.97 grams per mole. And oxygen is around 16 grams per mole. Adding all the values up gives us a final answer of 310.18 grams per mole. So the junior tutor said, calcium phosphate is given by the chemical formula Ca3PO4 we must multiply the atomic mass of each element and multiply it to the number of atoms present and add all the values. So they showed their work and also got 310.18. So this solution is correct. Question 12 says, when iron rusts, solid iron reacts with gaseous oxygen to form solid iron 3 oxide. Write a balanced chemical equation for this reaction. So they kind of worded it out for us. We know that we have solid iron reacting with O2 gas to form iron 3 oxide. So when we have iron 3, this means that the iron had a 3+ charge, and oxygen usually has a -2 charge. So we can write this iron oxide as Fe2O3. And now we just need to balance this. So I'm going to write a 3 in front of O2 to make it easier to balance because we have an odd number on the product and an even number on the reactants. So now we have 6 oxygens on our reactant side, so I just need to add a 2 in front of our iron 3 oxide. And now we have 4 irons, so I'm just going to add a 4 in front of the iron solid. So this is the balanced chemical equation. And the junior tutor showed the initial equation. To balance this, we must first start with oxygen, since there are 3 moles on the products, 2 moles on the reactants. This can be balanced by placing 3 beside the oxygen in the reactant side and 2 beside iron oxide in the products. And then they balance the iron. Yep, so the solution is correct. Question 13. What is the boiling point of methanol at 25 millimeters of mercury if its normal boiling point is 64.7 degrees Celsius and delta H VAP is equal to 35.21 kilojoules per mole? So this can be answered using the Clapeyron equation. Which states that the ln of your final pressure over your initial pressure is equal to delta H VAP divided by R times 1 over T1 minus 1 over T2. So the value of R is the ideal gas constant, which is 8.314 joules over moles times Kelvin. P1 is given in the equation or in the question, 25 millimeters of mercury. P2 will just be equal to the pressure at standard temperature and pressure values, which is 760 millimeters of mercury. T2 is equal to 64.7 degrees Celsius, but we are going to convert it to Kelvin just to make everything in the same units. So we're going to add 273.15 to 64.7 to give us 337.85 Kelvin. And then finally, delta H is given as well, 35.21 kilojoules per mole. Okay, so let's plug in all the values. Ln 760 divided by 25. And then I'm going to convert the delta H to joules, just because our R value is in joules as well. So just multiplying this by 1,000, we have 35,210 joules per mole divided by R. One over T1 minus 1 over 337.85 Kelvin. Okay, so let's try to simplify this. So I did the calculations in advance. And we're pretty much just solving for T1. And you should get T1 equal to 365.5 Kelvin. Okay, so the junior tutor used the Clausius-Clapeyron equation as well. They showed how they got all of their values, plugged it into the equation, and also got 365.5 Kelvin. So the solution is correct. I think I got time for one more question, which just asks, what is the Lewis structure of hexane? So hexane has a prefix of hex, which is equal to 6. And the fact that it ends in ane just tells us that there are only single bonds in the hydrocarbon. So all we need to do is write out 6 carbons and then fill out the remaining bonds with hydrogen. So carbon likes to form 4 bonds. So I just need to draw 2 hydrogens for all of the middle carbons, and then 3 for all of the end carbons. And this is the Lewis structure of hexane. There are no lone pairs or anything. And the junior tutor said, hexane is a chemical made from crude oil. So they just give a lot of background information on hexane, an unbranched alkane containing 6 carbon ions. It's a nonpolar solvent and a neurotoxin, alkane, and volatile organic compound. They have the molar mass, density, and here's the Lewis structure. Yep, so the solution is correct. Okay, so that is all the questions for this session. And if you like today's Q&A and you'd like to be notified of when we do this next, please hit the subscribe button and notification bell below. And if you'd like to submit a question of your own, then check out the links in the description. And don't forget to leave a like and a comment if you enjoyed today's video. And also if you want to share it with all your friends and classmates if they needed any help with chemistry. This has been Donna from OneClass, and I hope to see you soon. Bye.